Good evening. Okay, we are live. All right. Good evening. How are you all? Okay, let me share the live link first. Okay, give teacher 1 minute. Okay, so as promised, today we're going to end chapter 2 for differentiation. And I hope this will be very helpful, especially I know many of you are having exam next week, correct? Okay, many of you are having exam next week, so all the best. But let's finish up today until the application part. Okay, today we're supposed to continue with the table method first. Okay, after the table method, then teacher will go to the application part, which I've written down as the description for today's class. Okay, just give me 1 minute. Let me share the link first. Okay. Okay. Okay, done. All right, so let's continue with the table method, okay, for uh, chapter 2, differentiation. Hi, Kirtana, how are you? Okay, so let me start off from here. Find the nature of the turning points for the curve. So if you all used last week's method, okay, you all used last week's method, you all supposed to get this answer. Negative 1 over 2, 3 over 4, and then another turning point is 1 and 3. Okay, if you all followed last week's method. Okay, but today teacher is going to show your table method as promised, because table method is in your textbook. Okay, it is in your textbook, so it's better to know the table method as well. The other method that teacher taught you all last week was second derivative. Okay, remember second derivative, huh? Okay, let me start off first. Okay, first step, you want to find the nature. Okay, always start by finding the dy dx first. Okay, so in this case, your dy dx here will be 12 x squared minus 6x minus 6. Okay. Yes, okay. Then from here we find the roots. Okay, let your dy dx equals to 0. The reason you're making it equal to 0 and finding the roots is because you want to know the points. So turning points means you need the x and the y. So right now what we are doing is we are finding the x first. Okay, we're finding the x first. After find the x only, you can find the y. All right, so let's find the x. Okay, so 12x squared minus 6x minus 6, you equal it to 0. Key in to the calculator. Okay, degree 2, 12, negative 6, negative 6. Okay, I'm getting one of my x value. I'm getting x equals to 1. The other x value, teacher is getting x equals negative 1 over 2. So when I write inside the bracket, it's going to be x minus 1 and 2x plus 1. Okay, so you already got 2x value. From here, let's find the y. Okay, so when your x is 1, what will be the y? We ganti into the y equation. Okay, so y equals to 4 times 1 power 3 minus 3 1 power 2 minus 6 1 plus 2. Okay, this entire thing you substitute into the you key in the calculator, you will get the value -3. Okay, do the same thing for x -1/2. Okay, x -1/2. So you key in your calculator. Okay, -3 -1/2 -6 -1/2 plus 2. Okay, here the y you will get same like the answer teacher gave up there, 3/4. Okay, y is 3/4. Okay, once you get both this answer, that means you know you have two turning points already. Turning points. Okay, one turning point is 1 -3, and the other one is -1 and -3, right? 1 and -3. Yes, then the other one is -1/2 and 3/4. Okay, up to here when you find the turning points. This part itself you already get up to 3 marks. Okay, now from here is where we're going to use the table method. Okay, let me show maybe side here a bit how to use the table method. Okay, for both the points we have to use two different tables. Okay, the table has a format that you just have to like memorize and know. Okay, create 4 columns and 3 rows. Okay, 4 columns, 1 2 3 4, 3 rows, 1 2 and 1 3. Okay, 4 columns, 3 rows. Okay, once you already created the columns and rows, okay, the first one will be value of x. Okay, the second one is second one will be sign. What is the sign? And then the third one will be the sketch of tangent. Okay, so teacher just write sketch over here. Sketch of tangent is the full one. Okay, sketch of tangent, but if you write sketch also is fine. Okay, now the value of x for the first part. Okay, this one now we're going to do for the point -1/2 3/4. We're going to do for this point. Okay, we're going to start off with this first. Okay, only choose the x value only. Okay, so if x is smaller than -1/2, in the middle x is equal to -1/2, and the last column x is greater than -1/2. So you only need these three inequality sign. One is in the middle is equal, the other two is inequality sign. Okay, so you only need these three. Okay, after that, from here what you can do is you can choose the value. Okay, for the first one, choose any value smaller than -1/2. Okay, let's say we choose -1. Okay, teacher choose -1. Okay, what you do, you substitute that -1 value inside the what is that, dy dx. Okay, because you're going to see whether your dy dx, your gradient, because dy dx is the gradient, isn't it? Okay, so the sign, remember this sign you must ganti inside dy dx. So I better write down here for you also. Okay, the sign is for dy dx. Okay, ganti the -1 inside that. So let's see, let's check what's the answer. 12 times -1 square minus 6 -1 minus 6. Okay, teacher is getting a positive value here. Okay, I'm getting 12. So I'm just going to write positive because it's 12 is positive, there's no negative value. So we write positive. Okay, from here, next one, we ganti exactly -1/2. Okay, you ganti exactly. Okay, usually if you ganti exactly 1/2, you will get 0. Okay, you get 0, so you write 0. If you're not sure, you can always check back, because From the dy dx only we got one negative 1 over 2, right? So definitely it's going to be 0. Okay, next one. Let's choose a value x bigger than negative 1 over 2. Okay, I'm going to go for 1. I'm going to go with 1. Okay, let's try 1. Okay. Uh, so I'm going to ganti, substitute inside the x value for dy dx. So 12 times 1 square minus 6 times 1 minus 6. Okay. Um, what am I getting? Bigger than negative 1 over 2. Oh, I cannot choose 1 here because I'm getting 0 also. Okay. Do you understand why we cannot go for 1? Because if you choose 1, you're getting 0. And do you realize here your values were actually just now 1 and negative 1 over 2? So we cannot choose 1. Okay, go for another different, choose another value. Let's say we go for 2. Okay, we choose 2. Okay, so I'm just going to change back just now. Choose 2. I'm getting 30. So it's a positive value. Therefore, I'm going to put here positive. Okay, if it's positive, your gradient sketch of the tangent positive gradient will look like this, going up. If it's 0, it's going to be straight, horizontal. If positive, okay, again is going to go up. Okay, so far so good. Okay, let's check. X2, right, just now. 12 2 square minus 6 times 2 minus 6, getting positive. Mm, if I wait, let me check 1 minute, because this one we are getting the graph like this. Okay, if I choose negative, smaller than negative 1 over 2, bigger, let's say I choose 0. Okay, let's not go to 2. Okay, let's not go to 2. Let's choose a value, one value bigger than negative 1 over 2. Okay, let's choose one value bigger than negative 1 over 2. Okay, bigger than 1 over 2 means maybe we can go for, let's go for 0. Okay, let's go for 0. Just like go slightly above. Don't go too much until 2, 3, 4 like that. Just go slightly above. Okay, in this case, if I substitute 0 inside the dy dx, I will get a negative value. Okay, so that means this is not positive. This is a negative value. Okay, if it's negative, the sketch of our tangent will go down. Okay, the sketch of tangent will go down. So why don't go more than like 2 or 3? Because, okay, first of all, you always check what is the another x value. Okay, so that one you should not choose. Okay, don't choose that one. And then if you choose any value bigger than this, now the 1, right? 1, that's not teacher choose 2, right? Okay, that is already bigger than 1, correct? So that one you can apply for the another table. So we're not going to apply for this table. This table, the values that you're going to choose is just like within the range of uh, what is smaller than negative 1 over 2 and bigger than 1 over 2. Okay, I hope you're getting it. Okay, like for example, just now teacher choose x equals to 2, right? Okay, the reason why should not choose x equals to 2, because in your answer here got already x equals to 1. Later when you do another table, right, we're going to do another table after this. So later when there also will be one part here x bigger than 1, so later part I need to choose the 2. So this answer will be more appropriate for the another table. So that is why we don't choose 2 for this current table. Okay, I hope I made myself clear here. Okay, because if not, yes, it can feel like be confusing, like why teacher we don't choose x equals 2. Okay, okay, so here does not teacher choose x equals to 0. Okay, all right, so we have going up. So your graph is something like this. Okay, Therefore, the point negative 1 over 2, 3 over 4 is a maximum point. Okay, so now you already proven it's a maximum point by showing the sketch of the tangent. Okay, now we do for the other table. Okay, the other table, okay, we draw first 4 columns, 3 rows. 1, 2, 3, 1, 2, 3, 4. Okay, I need to move a little bit. Okay, so the first one, what we're going to write? We're going to write down the value of x, then the sign. Okay, value of x, the sign of dy dx, and the sketch of tangent. Okay, so for this, the point that we are going for is point 1 and negative 3. Okay, so here we put x smaller than 1, x equals to 1, x greater than 1. Okay, okay, let's start with, okay, the x equals to 1 is very easy. Sign will be 0. Equal means straight away 0 already. Okay, smaller than 1, let's choose one number smaller, which is 0. Okay, substitute the 0 into the dy dx just now. Okay, the dy dx just now was, let me write down the dy dx here. 12x squared minus 6x minus 6. Okay, so I'm going to substitute 0 inside. So I'll get negative 6. Okay, negative 6, so the sign is negative. Okay, now I'm going to choose a number bigger than 1. So just choose like one number bigger. Okay, so here we will get, let's say I choose 2. So if I substitute 2, just now when teacher substitute 2, I was getting a positive value, right? Okay, square minus 6, 2 minus 6. Okay, I'm getting 30. So this is positive. Okay, therefore, when you sketch the graph, okay, negative will go down, 0 will be horizontal, positive will be going up. So therefore, your graph for this one, particular one, will be a smiling graph. So your point 1, negative 3 is a minimum point. So this is how you use table method to show maximum point, minimum point. So of course the second derivative method was easier, right? Because it was quite faster, like, it was faster for us to solve. Okay, so now we go to solving problems. Okay, the application part, solving problems for maximum, minimum. Okay, if you look at the questions, right, it's going to be like you need to know a lot of like different formulas, like what's the volume of cylinder, what's the surface area for cylinder, trapezium. So teacher would suggest write down all these formulas in a book or A4 paper, or you have a notebook for AdMaths. Write it down and make sure you keep it beside you whenever you do these kind of questions. Okay, it will be really helpful for you. Okay, how about number 3 here? Okay, did you all manage to get this answer or not? Find the value of a, find the coordinates. Did you all try? If yes, okay, maybe I can just show this one more, last one. Okay, okay, even the function here has a minimum point. Okay, minimum point when x is equals to 1. Okay, find the value of a. Okay, they already say it's a minimum point, therefore they have already done the dy dx, that's why they got the minimum point. Okay, so first step, what you do, okay, you find the gradient first, the dy, you differentiate first. Okay, ax squared minus 12x minus 4. Okay, let's differentiate. We get 6x squared plus 2ax minus 12. Okay, one of the minimum point value is x equals to 1. Therefore, if teacher substitute x equals to 1 inside here, okay, inside here, plus 2a1 minus 12 must equal to 0, because when you solve the dy dx equals 0, that's when you will get the x value, isn't it? So now what you do, you just substitute that x value and you make it equal 0. It's the same process only. Okay, it's the same process. When I'll repeat one more time. When you want to find this x value, you will usually do dy dx equals 0. Then only you can get the x. But now you already got the x, so you substitute that x inside and you equal it to 0. So from here we will get the a value. Okay, so let's solve this. 6 minus 12 is negative 6. Okay, and then 6 bring to the other side, and a now bring the 2 to the other side. We get a is equals to 3. Okay, what's the coordinate for the maximum point? Okay, so go back to your equation. Okay, go back to the equation y, right? Okay, y equals to 2x cubed plus, okay, this time the a you substitute as 3x squared minus 12x minus 4. Okay, from here you find your dy dx. So we will get 6x squared plus 6x minus 12. Take your dy dx and make it equal to 0 so that you can find the point x. Okay, one of the point we know already, we will definitely get x equals to 1. But another point only we don't know. So the don't know one only will be the maximum point. Okay, because the another one is already minimum, but they already tell it's minimum. Okay, so minus 12 equals 0. Okay, we can use our calculator. 6 and negative 12. Okay, 1 and negative 2. Okay, teacher's getting x equals to 1. The other one negative 2. Okay, so here x minus 1, x plus 2. Okay, so we already know negative 2 is going to be the maximum point. You don't have to prove. Okay, no, there's no proving here. It's automatic because x equals 1 is minimum. But right now what we need to do is we need to find the what is that? We need to find the y value. Okay, we need to find the y value. So let's find the y. So when x is negative 2, y is just ganti inside the y. 2 negative 2 power 3 plus 3 negative 2 square minus 12 negative 2 minus 4. Okay, so from here y is 16. So the maximum point is negative 2 and 16. Okay. Okay, now teacher already completed this part, negative 2 and 16. So let's do the solving the problem for minimum and maximum point. Okay, let's look at this. Okay, this one is quite interesting because there are few things here that generally you need to know. You cannot solve if the first part itself you get stuck and you were not sure. Okay. Okay, solving problems involving minimum, maximum. Okay, let's read the question first. Okay, the surface area of a cylinder can with lid of radius r 300 cm square show that the height h is given by h equals to 150 minus pi r square over pi r. Okay, Can you see here? There's one important information. Surface area, okay, is 300 centimeter square. Okay, what is the formula for surface area of a cylinder? Now this is very important. If let's say you don't remember, uh, just Google it up. Okay, write it down in your book first. Okay, the teacher already write down here. I have my surface area, which is 2 pi r square plus 2 pi r h. Okay, using this you need to show the height is equals to this. Okay, therefore, okay, you see carefully your question. The final answer for the h, okay, pi they write as pi, r they write as r. So don't change the pi to uh 22/7 or 3 point. Don't change. Okay, don't change. Okay, so let's start. A, okay, surface area. Surface area is 300 centimeter square. That means 2 pi r square plus 2 pi r h equals to 300. Okay, r is r, isn't it? Because the question also say radius is r. Radius is r. There's no number for us to substitute. Okay, from here what you do, you express the h. The others all we are going to bring to the other side. Okay, so let's start with uh, 2 pi r square. I'm going to bring to the other side. So 300 minus 2 pi r square. Then you can bring only this to the other side. You can like cut off, because we want to prove the h is equals to this. So we cut off that part and we bring it to the other side. So h is 300 minus 2 pi r square, okay, over 2 pi r. Okay, this one what you can do is, okay, the 2, because we want to make it look like the question, right? Show this one. Okay, we want to make it look like this. If you realize there's 150, 300 no more already, so that means the 2 here I must cut for this and also for this. You can cut for both because the 2 belongs to both of them. Okay, so here now our h will be 150 minus pi r square over pi r. Therefore, you have shown that the h is equals to this. Okay. Okay, next one. B. Find the values of r and h so that the volume is maximum, and hence find the maximum value. So we got 3 things here. We need to find the value of r, we need to find the value of h, and we need to find the maximum volume. Alright, let's get started. So if now we are going to deal with volume, okay, you need to know what is the volume of a cylinder. Okay, so you see or not, now there's like a lot of formulas that you need to know, right? Okay, the volume for a cylinder is pi r square h. Okay, we start with that pi r square h. Okay, find the values of r and h so that the volume is maximum. Okay, your keyword here, maximum. The moment they mention this, that means you are already doing differentiation, because maximum and minimum can only happen when you have maximum and minimum can only happen when you do differentiation. Without differentiation, you cannot get maximum point or minimum point. Okay, so therefore volume is maximum. Okay, so if volume is maximum means, how do I differentiate this. What should I use? Because this is now something to do with volume. It's like this. It's V equals to pi r square h. So if I want to differentiate volume, I must differentiate with respect to what? Is it with respect to pi? Is it with respect to r? Or is it with respect to h? Okay, let's see. If we have students watching live, do you think we must do with respect to r or with respect to h, or how? How do we identify? This can be like tricky question because is this one is like common in SPF. Trial papers, okay, like your media exam, this will be common. Let's see. Let's give like 1 minute. Let's see if you can let me know. If not, then teacher will guide you all. But let's give a try. Is it with respect with R, H, or pi? Okay. Kirtana said both may be, teacher. Okay. But you cannot differentiate with both, right? You cannot find dv dr and dv dh at the same time. Okay, we only need one. Okay, so this is where, okay, remember from question A, okay, they asked us to show the h, isn't it? Okay, since from, so this one you have to relate with question A. Okay, since the question A got h, so what you must do here is the volume here you must substitute the h first. Okay, we substitute the h first. 150 minus pi r square over pi r. Okay, I think pi we can cut, r also here power 1. Okay, so your volume now looks something like this, 150 pi r square. Okay, then I'm going to times the r in, so 150 r minus pi r cube. Okay, can you see now you won't be confused anymore. You can straight away differentiate with r. And you definitely cannot differentiate with pi because when you do differentiation, it must only be with a constant. Pi is not a constant. Pi is actually got value 3.142 or 22/7. But r, we don't know what is r is a constant. Okay, so we differentiate with constant. So when you do like this, ready, it's easier. So you don't have to guess whether I must differentiate with h or differentiate with r. Okay, now let's differentiate this. We will get 150 minus 3 pi r square. Yes, correct. Okay, 150 minus 3 pi r square. Okay, from here, okay, we already differentiate this. Therefore, let's find the value of r because they say that the volume is maximum. Okay, so we let the dv dr equals to 0 first. Okay, so 150 minus 3 pi r square equals 0. Teacher is just doing the same method that I did just now. We want to find maximum minimum point. We let it equal to 0 first. Okay, so from here let's find the r. Okay, 150 equals to 3 pi r square. 3 pi bring to the other side, so becomes divide. R square, so the square bring to the other side, becomes square root 150 over 3 pi. Okay, let me see if I can get a value for this or not. Square root 150 over 3 pi. Okay, I'm getting 3.98, 3.9894. 3.9. Okay, so teacher is going to take the a bit longer one. Okay, if let's say you don't want to give your point, your answer in decimal, you want to leave in cert also can. Okay, you all learn form 4 cert already, right? Okay, you can do the cert method also. Okay, but teacher is going to give in point form. So 3.9894. Okay, so r value we got already. Okay, so r is done. From here, let's find the h. Okay, how to find the h? Remember just now you from question A, we got the H, right? So we just ganti everything inside there. Okay. So copy back just now what was the H? 150 minus pi r square over pi r, isn't it? So we just ganti the value of r inside here. So 150 minus pi 3.9894 square over pi 3.9894. Okay, so we key in into the calculator, you get the H 150 minus pi 9894 square divided by 3.9894. Okay, I'm getting 7.9789. 7.9789. Okay. Okay, correct. So this is H and R. H and R done already. We already found the value. If let's say, teacher, if I use 3.142, will it be wrong? No, but your decimal might differ a bit. Like it. Because the question didn't state what to use. Yes, because the question didn't state. So if you use 3.142 or you use 22 over 7, the decimal might change a bit, because pi, if you look at the value of pi, the actual value, right, it's very long, right? It's 3.1415926. So if you take 3.142, it's not wrong, but your decimal value, the behind part, will change a bit. Okay, that's all only, but it's not wrong, it's still correct, okay. Okay, we already got the H, we already got the R, and shall we continue to find the last part, which is find the maximum volume. So what is the maximum, what is the maximum volume? So volume, go back to the question, this one, go back to the formula, V equals to pi r square H. So we substitute the R and the H, okay? Okay, so let me do here, V equals to pi r square H. So just now our R value 3.9894, 3.9894 square. H was 7.9789, 7.9789. So we just key in calculator, 3.9894 square, 7.9789. So you'll get 398.94 centimeter cube, because this is volume. Okay. So at least we successfully done turning points and then the application part. Okay, let's go to the last part for chapter 2, differentiation. Okay, we go to the last part, which is, okay, these two very important. You need to know how to do rate of change and how to do small changes. It's very easy, actually, it's easy, but uh, a formula is not given in exam. That's the only thing lah. Okay, formula is not given. Okay, now rate of change. We start with rate of change first. Okay, what is rate of change and how to apply? Okay, the moment you see the word rate, rate means changes that happen with time. Okay, these changes that happens with time. Okay, so you have to remember time here, because like anything that is changing in life, anything also, for example, okay, we are growing up, okay, our height is changing every year. Okay, so when your height is changing, it's changing according with time, right? So time is also running at the back, I mean time is also going on. So any rate that you're going to learn for this part of the chapter, you have to remember time. Okay, so we are going to use the formula dy dt. Okay, dy dt very easy. All you need to remember is put the dy at the top and put the dt at the bottom, the other side. In the middle here will be dx and dx. Okay. Now, this formula it's not given in exam because sometimes different types of question. For example, okay, teacher give a cube. Okay, teacher give a cube. Let's say I am pouring water inside the cube. Okay, cube can I use y? Cannot. I will use v because it's volume. So it will be dv dt. So when dv dt, you have to form the formula which is dv at the top, okay, and then times with, okay, here will be your dt. So what will be in the middle? The middle will usually be dx, but sometimes it can be different also depending, okay. So I hope you get the picture first, okay. Now teacher show you example, okay, then you will feel like more clearer, okay. So example 1, okay, given y is equals to x square plus 4x plus 3, okay, and the rate of change of x is 0.5 unit per second when x is 2. Find the rate of change of y. Okay. Okay. First step, analyze the question first and understand. Okay, this is your y. Rate of change of x. That means this one is dx dt. Whenever you see the word rate, straight away must have dt at the bottom. That's your clue. Okay, dx dt. Okay, find the rate of change of y. That means they want you to find dy dt. This is what you must find. Okay, now let's form the formula. So dy dt equals to, you write dy at the top, then you write dt at the bottom, the other side. In the middle, we're going to use x because here they say rate of change of x. So here dx, here dx. Okay. Now, dy dx, do we have from the question dy dx? We don't have, but we can find from here. We can use this to find dy dx. Okay. Do we have dx dt from the question? Yes, this is the dx dt, 0.5. Okay, so now let's find dy dx first. Okay, so we do side working, find dy dx. This is 2x plus 4. Okay, remember for rate of change, rate always changes with a value. So you cannot have x there. So what you do, you substitute the x equals to 2 inside. That's why they give you the x, okay, so that you substitute. So 2 times 2 plus 4, that means 4 plus 4, 8. So your dy dx is 8. So here 8 times dx dt is 0.5. Okay, so 8 times 0.5 is 4. Oh, okay, it's 4. So the answer will be 4. Okay, you want to follow the unit, you can follow, which is 4 unit per second. Or if you just write your answer like this only, 4 only is also correct. Okay, so this is quite straightforward and simple. Okay, straightforward and simple. Okay, now let's look at the next one, number 2. Okay, the number 2 will have a different letter that we might need to use. So usually in SPM, it comes out like using different letters because of the application. Depends on the application. Okay, now let's look at number 2. Okay, the sides of a cube increases at a rate. Okay, you see the word here, rate, okay, of 1.4 centimeter per second. Find the rate of change of volume when the side measures 5 cm. Okay, first of all, let's identify what letters to use. So I'm going to use S for sides, and the other one I'm going to use V for volume. Okay, so usually you identify and write it down. Okay, so this 1.4 is the rate. What rate? Rate for the change of sides, isn't it? So it's ds dt. The moment you see the word rate, you straight away write dt at the bottom. Okay, find the rate of change of volume. That means you're finding dv dt. Okay, we are finding dv dt. Okay, now let's form the formula. So dv dt is equals to dv times, over here is dt. Okay, what will be in the middle? We cannot be x, so it definitely has to be s. So ds ds. Okay, then from here, do we have dv ds? So far looks like don't have, but we have ds dt, which is 1.4. Okay, so now it looks like we got some extra work to do first, which is we need to find dv ds. Where do I find dv ds from? Now, if you remember here, this is volume of a cube, isn't it? Okay, what's the formula for volume of a cube? If you want to find cube, they say that the sides, these are all sides. Okay, so the side is S, S, S. We write as S. Don't write L, 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 because I know most of the time students use length, right? Length, width and everything. So we write here S, 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 because sides for cube will be same. So the volume is S times S times S, which is S cube. Okay, so this one you have to create that formula for this volume. So from here you differentiate, you will get 3s squared. Okay, now the s you cannot leave it like that because we need the value. So you substitute the 5 because they say side is measuring 5 centimeter. So here becomes 3 times 5 square, which we get 75. Okay, so from here you already know your dvds. So 75 times 1.4, we get 105. So if you're not sure with the unit, you can leave it, but most of the time the unit's very easy. This one that you're finding is dv dt, isn't it? So up is v, volume. Volume is centimeter cube. Down is time. Time is second, per second, -1. So you can write your answer as this. Okay, easy, right? Actually this is not too bad. Okay, this is actually easy. Okay, we go to question 3. Okay, let's go to question 3. Okay, question 3 we have, okay, the volume of a sphere decreases. Okay, it's a big keyword here, decreases at the rate of 4 centimeter cube per second. Find the rate of change of the radius of the sphere when the radius is 3. Okay, we have a sphere, so looks like we have to use V for volume. Okay, and the other one here we have is radius, so I'm going to use R for radius. Okay, now sphere, what is the volume of a sphere? See, this is where you need to know the formula again. Okay, so volume is 4/3 pi r cube. Okay, so make sure you know volume of sphere. Okay, this one, the one they give us here, the volume of a sphere decreases, okay, at the rate. So when the moment you see the rate, that means dv dt. Okay, since it's decreasing, you have to put -4, not just 4 only. Okay, we have to put -4. Okay, find the rate of change of the radius of the sphere. So we are finding dr dt. This is what we are finding. Okay, now use that and create the formula first. So dr dt is equals to, okay, dr at the top here, dt at the bottom here. In the middle will be dv dv. Okay, so far following. Okay, dv dt, this one we have the value here, -4. But dr dv we have to find using this, the volume. Okay, let's do some side working first. Let's find dv. Let's differentiate dv with dr. Okay, although here it's terbalik, right? It's okay. You find the dv dr first, then later you can terbalikkan the thing. Okay, so here when I differentiate by r, okay, the 3 go in front times with the 4/3, which you get 4 pi r square. Radius they got give us, isn't it? So we ganti the value of the radius, which is 3 square. You can leave the pi just like that, so you don't kacau the pi. So you get 36 pi. Pi teacher is not going to kacau because the question also didn't tell pi we need to substitute as what, right? So you just leave it. Okay, okay, now let's ganti all our values. Okay, let's substitute all our values. So dr dv, since this is terbalik, okay, it's the opposite, therefore you have to put 1/36 pi, okay, times with -4. So just take the numbers and you times, okay, so you'll get -1/9 pi. Okay, this is your answer already, and since radius is centimeter, time is per second, so you can leave your answer up to here. And you're getting in negative because the volume is getting smaller, so radius also must get smaller. That's why you get negative answer, which is correct. Okay, must be suddenly you get positive means there's something wrong the calculation. Okay, so we are done ready. Last one we have one application question for rate of change. Okay, let's do that one and then we will finish up with the small changes question. Okay, we finish up with that. Okay, let's see the next one. Application. Okay, so far any question, like so far this is fine, right? This is like okay, can do. It's not like so hard or anything. It's just that you must know formulas. You must know how to relate, what letter to use. Okay, that kind of things only. Okay, we go to application. Interesting. This one is also again a cylinder. Okay, let's look at this. Okay, water is leaking. Okay, how funny is it? Because for the past 2 days, teacher's house, one of the bathroom, the water is leaking also. Finally, tomorrow, someone is coming to repair it. Water is leaking, okay? Okay, water is leaking from a cylindrical tank of radius 20 centimeter. Okay, radius is 20 at a rate of 500. Okay, rate. So that means straight away you know that this is something dt. Okay, something dt. Yeah, but what dt? Is it volume? Is it the radius or what? Okay, find the rate of change of water level. So this one also over something. What is that water level? What is it referring to? Is it L, water level? Okay, now see carefully. This is rate centimeter cube. Okay, if you realize this is power 3. Power 3 is always has something to do with volume. So this is dV dt. Therefore, we're going to use V for volume. Okay, how about the rate of change of water level? You want to use L. Okay, if can, don't go for L because look at the diagram. The diagram already got water level represented by H, which is height. So therefore, we're going to find dH dt. So the water level we don't use L, okay, we use H because the diagram already got H there. Okay, can see how to relate. Okay, this is how you relate. Okay, then from here, we need to know the volume, isn't it? Okay, so H is we are going to use for height. You can write height or you can write water level. Okay, it's either one of it. Okay, all right. Now from here we're going to find dH dt. So let's form the formula first. Okay, dH dt is dH then dt at the other side. Okay, in the middle here will be dv and dt. Okay, dv dt we have, which is 500. Okay, dh dv don't have, we need to find. Okay, water is leaking. Now leaking means the volume is decreasing or increasing. So obviously it's decreasing, right? So don't forget here you must put negative 500. Okay, so that's the thing there that you must be able to apply. Okay, now what is the volume for cylinder just now? We already write this now, right? Pi r square h. Okay, so from here let's find dv dh. Okay, differentiate the v with respect to h. Okay, oh, before that, I think we need to substitute the radius first. Okay, let's substitute because radius mm, 20, isn't it? Okay, so we substitute the radius first. So pi 20 square h. Okay, so we get 400 pi h. Okay, now we differentiate. Okay, dv dh. dv dh we will get 400 pi. Okay, so this value we put into the formula. So 400 pi times negative 500. Oh, you cannot use 400 pi. You have to terbalikkan the thing. You have to change the opposite way because this is dh dv. So it's 1 over 400 pi. So the pi, you don't have to substitute anything. Just take 1 over 400 times negative 500. So you get negative 5 over 4 pi. Not sure what you need to use. See your question, which is dh. Height is centimeter. Time is per second. Okay, that's all. Okay, so far, any question? Actually, we are done already with rate of change. Okay, so we can go to the last part, which is small changes. I hope you all copy down already. Okay, teacher's going to go to the last part because actually after this I still have one more class, okay, for my form 6 student. So I have to finish up before 10 o'clock. Okay, all right, let's do the last part. Okay, small changes and approximation. Okay, why do we learn these small changes and approximation is because, okay, this chapter, if I remember, I got tell y'all in the beginning, like engineers use this chapter, okay, maybe architect people, because like when you do some changes, like for example you're building a bridge or you're building some kind of, like building, there are small changes that you need to do. So like engineers and all, they need to calculate like how much, if I do the curve this much, how much changes would it make to, the amount of materials they need and all those things. Okay, so that's why here the small changes, all like sometimes in trial question you might see the small changes they will do like on breach and then that kind of things, because this one all can apply actually in real life. Okay, but now you might feel like teacher, why all these formulas and everything, if let's say like in real life where you can apply this in architecture, buildings and stuffs like that. Okay, of course, if you ask a doctor, I don't think so doctors are going to use this. Okay, but it's if you are taking at maths, and one of your ambition is to be a doctor, the capability and the skills that you have to solve all these questions will shape you to be a better human as you grow up, like you become a better adult. People say, teacher, we don't use maths every day in life. True, but the problem solving skills, you do solve a lot of problems every day in life, right? So all the skills comes from where? From doing this kind of questions, exercises. Although you don't directly use it, but it indirectly actually impacts the way your skills, okay, like the way you do solve things in life. Now you see some people don't really know how to immediately think and respond to solve. That's because maybe they don't really do much exercises. Like some people are very creative, maybe because they do a lot of arts. Some people are like very sharp because they do a lot of maths. Okay, they do a lot of maths, physics, this kind of thing. So problem solving is a skill. Okay, it's not everyone can do problem solving. So that's why it's important you do learn maths. Yeah, sometimes I get questions from students, teacher, why we learn maths? So that's my answer. Okay. Okay, let's look at the last part. Okay, small changes and approximation. Okay, this one you need to know this formula and you need to know this formula. These two are. Okay, let's look at the first one. Okay, small changes you have to use delta. You have to put the d like that. Okay, you cannot just write normal d, you will get wrong. uh, if I write delta y, that means small changes in y. If I write delta x, that means small changes in x. Okay, it depends. Okay, delta. Approximate value, how to find? You just take the y origin plus delta y. Okay, how to find this delta y? That's why we need to know this formula, and then from that, whatever answer you get, you have to substitute into the second formula. Okay, now I'm going to use these formulas and apply for the first example. Okay, let's look at this. Given y is equals to 8 over x squared. If x is increased from 2 to 2.01, okay, can you see that very small change? Right, a very small only, 2 to 2.01. So that's why it's called small changes. And I got guide you all previously. Delta means, what does delta means? Delta means small changes. Okay, delta actually means small changes. Okay, okay, so from here, find the approximate change in y. Okay, the first one, approximate change, means we are finding this, the delta y. Then the second one, find the approximate value. That one we are doing the second formula, approximate value. Okay, so remember, whenever x is changing, definitely y will also change, because whatever affects the x will affect the y. For example, if let's say today earthquake happened, will all the position of the building still be the same? Or there will be some small changes. There will be, okay, some small changes. Same goes, like even if you throw a stone into the river, okay, or like into the sea, do you know that the entire wavelength of the, like the sand, okay, the whole wavelength changes? I think most of us didn't know that, right? Like I was even shocked when, like, once upon a time, very many years ago, when I found out, like just one rock or like one stone you throw into the beach or like the sea, the entire wavelength at the bottom that changes. So you can just imagine how much impact this delta, okay, the small changes happen. Okay, so okay, let me go back here. Okay, let's do the a first. Okay, y equals to 8 over x squared. I'm just copying. Okay. Find the approximate change. Okay, let's use the formula delta y. Okay, delta y equals to dy dx times delta x. Okay, what is delta x? Delta x is actually, okay, this one all you need to do side working first. Small changes in x. That means you have to take the 2.01 minus 2, which you get 0.01. Okay, you get 0.01 first. Okay, this is your delta x. What is dy dx? Okay, let's find your dy dx first. Okay, this one, bring the x to the upper part. Okay, so here we get negative 16x power negative 3. Okay, don't leave your dy dx in x. You have to substitute the value of x inside here, which is the value of 2. Substitute the original one. Okay, substitute the original one. So what you do, you bring it down. Okay, negative 60 over 2 power 3. Okay, so what is the dy dx here? I'm sorry, I'm having a little bit of flu going on. Okay, so this is negative 2. Okay, this value only now we substitute inside here. So delta y is negative 2 times 0.01. So we get negative 0.02. So that means when the x is increasing a little bit, the y delta y here is decreasing by 0.02. Okay. Okay, the approximate value, we use the formula. This is for B. So how to find the value of y? You want to know the exact value of y. So take the y origin plus the delta y. Okay, what is the y origin? Where is the y origin? Okay, y origin, this one also we do side working first. Okay, y origin. Okay, the original one is at 8 over x square, isn't it? Okay, this one, you substitute the x value as 2 first. Take the original value of 2. 2 square, which is you get 2 also. Okay, so y origin is 2. 2 plus with delta y, just now we got the answer, negative 0.02. Okay, so 2 plus negative 0.02, I'm getting 1.98. Okay, can you see? So when the x is increasing 0.01 there, okay, the y decreasing 1.98. So that's what it means here lah. Okay, so this is where small changes and approximations happen, like using these formulas. Okay, so I think we are done already with the entire chapter. Okay, for the SPM clone questions, okay, teacher give you all the final answer only. Okay, so that you all can practice the answers. Okay, practice the question and try to get the final answer as the one teacher giving here. Okay, so maybe you all copy down the final answer. Okay, for question 1, okay, the value of x when maximum is 1, y will be 12. Okay, just write down all the answers first. For number 2, approximate change. Okay, this one give a try. Okay, follow like the way just now we did. Approximate change will be delta y. So you will get 0.05. Okay, and then for number 3, application, just now that we did. Okay, the application part, rate of change. So please try this. Okay, this one you will get rate of change of water level. So this is dH dt. Okay, your final answer will be 0.30 centimeter per second. Next one, I think this is the last one. Okay, number 4, your final answer, find the rate of change of y. Okay, this one dy dt, you will get 0.4. Okay, and the last one, a rectangle piece, so that the fans are maximum. This one, calculate the length. Okay, the length will be 3.2 meters. Yes, the length is 3.2 meters. Calculate the length The length of 3.2 meter. Okay, I'll give you the length and the width, because this is rectangle, right? Okay, the length you will get 3.2, the width you will get 2 meters, and from there you have to find the length of the fence, so the entire perimeter. Okay, you have to find the perimeter. From there you will get 10.4 meters. So this, the first two teacher gave one is like your clue. The last one, that's the final answer, the perimeter. Okay, so next class, if there are requests from students, like you are watching live and you tell teacher, can you discuss maybe question 5, or teacher, can you discuss question 3? Okay, then I will discuss. Okay, if not, then the next class I'll go to integration. All right. Okay, so we end until here. I'll see you all next week. Okay, all the best for your exam, for those of you having exam. uh, Avoid careless mistakes. Make sure your formulas are there with you. Okay, you know, like chapter 1 and chapter 2 formulas, what to apply, product rule, quotient rule, and everything. And make sure also to check back once you finish. Okay, try to do it all within the time. Don't spend too long on one particular question. Okay, all right, so I'll see you guys next week. Take care, have a good night. Bye.